The following table displays the marks obtained by 50 students in a mathematics test, with the marks grouped into class intervals. The frequency column F indicates the number of students who scored within each interval. For example, 5 students scored between 0 and 10 marks, 8 students scored between 10 and 20 marks, 15 students scored between 20 and 30 marks, and so on. Our task is to find the mean, the median, and the mode of this distribution. Okay, to find the mean, first we need to calculate the midpoint of each class interval. The reason we need the midpoint in this case is that we are dealing with grouped data, where individual data points, such as each student's exact score, are not available. Instead, we have a range of values for each class interval, and we need to represent each class by a single value. For example, if 8 students scored between 10 and 20 marks, and we assign the midpoint of 15 marks to represent all these 8 students, we can then compute the total score for these 8 students as 8 times 15 equals 120. We represent this midpoint using x. To find the midpoint, we add the lower boundary and upper boundary of the class and divide by 2. For the first class, 0 to 10, midpoint is 0 plus 10 divided by 2, which gives 5. For 10 to 20, midpoint is 10 plus 20 divided by 2, which gives 15. For 20 to 30, midpoint is 20 plus 30 divided by 2, which gives 25. For 30 to 40, midpoint is 30 plus 40 divided by 2, which gives 35. For 40 to 50, midpoint is 40 plus 50 divided by 2, which gives 45. Now we multiply each midpoint by its corresponding frequency. Frequency tells how many students scored marks in that interval, so multiplying the midpoint by the frequency gives the total score of all students in that class interval. Now make this column, which will be F times X. So, for 0 to 10, 5 times 5 gives 25. For marks range 10 to 20, 15 times 8 gives 120. For 20 to 30, 25 times 15 gives 375. For 30 to 40, 35 times 16 gives 560. For 40 to 50, 45 times 6 gives 270. Now we add up all these products to obtain the total sum of F times X for each class interval. So we calculate 25 plus 120 plus 375 plus 560 plus 270, which gives a total of 1,350. This gives the total marks of the entire 50 students who gave the math test. Next, we add up all the frequencies, the number of students in each interval, to determine the total number of students. We calculate 5 plus 8 plus 15 plus 16 plus 6, which gives a total of 50 students. So the mean or the average marks of the students will simply be equal to this total score divided by the total number of students, or sum of F times X divided by sum of F, or 1,350 over 50, which equals 27. Therefore, the mean marks of the students are 27. Sweet. Next, we calculate the median. To do that, we first calculate the cumulative frequency for each class interval. Cumulative frequency means that for each class, we keep adding the frequency from the previous class to the current class frequency. This helps us track the total of the number of students as we move through the intervals. Make a column like this and call it CF for cumulative frequency. For the first class, 0 to 10, the cumulative frequency is simply 5, as there are 5 students in this class. For the next class, 10 to 20, we add 5, which is the cumulative frequency from the previous class, to 8, which is the frequency of this class, giving us a cumulative frequency of 13. This means the total number of students who scored 0 to 20 marks is 13. For the next class, 20 to 30, we add 13 to the frequency of this class, which is 15, which gives us 28. For 30 to 40, we add 28 to the frequency of this class, or 16, which gives us 44. Finally, for the last class, 40 to 50, we add 44 to 6, resulting in 50. The total frequency sum of f is 50, and half of the sum of f is 50, divided by 2, which equals 25. Then we find the median class. The median class is the class where the cumulative frequency is just greater than or equal to 25. Looking at the table, we see that for the class 20 to 30, the cumulative frequency is 28, which is greater than 25. Therefore, our median class is 20 to 30. To find the median, we use the formula: lower boundary of median class plus half of sum of frequency minus cumulative frequency before median class divided by frequency of median class times class width, or h. In this case, the lower boundary of the median class is this value, or 20. Then half of the sum of f is 25. Then the cumulative frequency before the median class is this value, or 13. Next, the frequency of the median class is this value, or 15. And finally, the class width is this upper boundary minus lower boundary, or 30 minus 20, or 10. Substituting these values, we get 20 plus 25 minus 13 divided by 15 times 10. This will become 20 plus 12 over 15 times 10, or 20 plus 120 over 15, which is 20 plus 8, or 28. Thus, the median marks are 28. Now, let's move on to calculating the mode. The mode is the value that occurs most frequently in a data set. For example, if this is our data set, then 22 is the mode here because this number appeared 3 times, which is the highest frequency. For grouped data, we use this special formula to calculate the mode. To begin, we first need to identify the class interval that has the highest frequency, as this class contains the most common values. Looking at the table, we observe that the highest frequency is 16, which corresponds to the class 30 to 40. Therefore, the modal class is 30 to 40, because this class has the greatest number of students. Now, let's break down and substitute the values for each part of the formula. The lower boundary of the modal class, or this L value, is 30. This is because the modal class is 30 to 40, and thus the lower boundary is 30. The frequency of this modal class, which is this F1, is 16. Then the frequency of the class before the modal class, which is this F0, is this frequency, which is 15. Next, the frequency of the class after the modal class, or the frequency of this class, which is F2, is 6. Finally, h, or the class width, is this upper boundary minus lower boundary, or 40 minus 30, or 10. Now, we substitute these values into the formula. 30 plus 16 minus 15, divided by 2 times 16 minus 15, minus 6 times 10. 16 minus 15 equals 1, 2 times 16 equals 32, and 32 minus 15 minus 6 equals 11. So the formula becomes 30 plus 1 divided by 11 times 10. 10 over 11 equals 0.91. Finally, add 30 plus 0.91, which gives 30.91. This means that the most common score in this dataset is close to 31, indicating that most students' scores are concentrated around this value. If you enjoyed this video, please don't forget to like, share, and subscribe to our channel. Also, you can support my channel by joining our community and becoming a member. So, good.